Hello everyone, welcome to Interesting Maths. Here we will have set of videos of interesting math problems which might be helpful for you across different disciplines, maybe physics or chemistry, and these topics will be definitely of use in the future grades as you learn different topics of advanced math. Let us look into the first topic, that is of scientific notations. Now, you can see over here there's a number express. Okay, it's 36, so it is 106 millions in scientific notation. Now, what does this mean? I will give you a little bit of hindsight why we do this. Now, think many years ago. Now we can store these numbers easily in laptops or computers or mobile phones. But say it is a long time ago, maybe 3 centuries ago, where they used to do a lot of discoveries in physics or chemistry. Sometimes the numbers, the distance between planets is huge, or the mass of atom or something very minute is very small. How can you get it in terms of a standardized form? Because you can't keep writing such huge numbers, isn't it? We need to get it into a tiny form or a easier form to write. So that's why they started thinking of numbers which is easy to multiply. Now what I mean by it is, instead of writing 20, can't I write it as 2 times 10? It's the same thing. It's 2 times 10, 20. But now this is looking more complicated, right? But what if I had 200? Now 10 can be easily multiplied by its powers. Like if you're thinking of the higher powers of 10, 10 power 2 is 100, 10 power 3 is 1000, because you just keep adding zeros. Whereas you take any other thing, say 5 might be simple. Now tell me, what is 5 power 4 without quickly? It's hard. You need to try thinking or multiplying. Whereas if I tell you what is 10 to the power 4, it's very simple. Just add 4 zeros to 10. So 1, 2, this is the answer, 10,000. So this is very easy. That's why we can write everything in terms of 10. So instead of writing 200, we can write 2 into 10 to the power, how many zeros? 2. So 10 to the power 2 is 100 times 2, it's 200. This is a simpler way to write. But we have to follow a certain set of rules and stuff. Now let's see what that is. Express 106 million in scientific notation. Okay, what do we do now? So you must always see where you need to start counting. Is it from right to left or left to right? This is one of the most crucial thing. Now, there are many methods. I will tell you a simple method. Look at this number. Can you see a decimal point anyway, like a full stop? It's only comma. No, I need a dot, decimal point, like 1.5. or 0.5. This is a decimal point. Is there any decimal point over here? No. Let's consider right to left. That means if there is no decimal points, okay, there's none. So consider the only numbers, right? Consider from right to left, because this is a big number. You go from right to left. Let's count. 1, 2, 3, 4, 5, 6, 7 and 8. What am I doing? Since there is no decimal point, that means I can write a decimal over here. It is same, isn't it? The decimal point is at the end, at the right end. So this decimal point is being moved from 1, 2, 3, 4, 5, 6, 7, 8. We are going to the first significant digit, that is over here, 1. Don't stop at 6, because you just need one significant number, point the remaining numbers. So if I bring this decimal point from here to here, so I need to write it after the first digit. There are 8 digits, right? So I need to write it as 1.06 into how many times I moved this, that is 8 times. Again, I will tell you, it's from here 1, 2, 3, 4, 5, 6, 7, 8. Therefore, this is the number 8. What next? That's it. Sorry, it's so simple. So now let's look into the next problem. And at the end of the video, after we solve both of these problems, I will tell you a shortcut to, guess which is the correct answer as well. Now over here we have a decimal point and so many zeros and the digit like this. This is a very, very small number. Now how do you represent it in a standardized way, in a scientific notation? Very simple. See, the decimal is over here. So you need to move it to the right because this is your first significant digit, isn't it? So you have to move it from left side to the right side. Now you must always remember, right to left, I forgot to tell you a while ago, is plus. So this number, when you write 8, is always plus. Whereas now you're moving from left to right. So let's count. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you're bringing the decimal point over here. It'll be 5.61. So it's 5.61 into 10 digits. We are moving the decimal by 10 digits. So we write 10, but what about this negative sign? Because it's moved from left to right. That's why it's negative. This negative number denotes it's a very, very small number. As you can see over here, it's negative 0.00 so on. There are 10 zeros basically. So this is the way to easily write in scientific notations. But what is another way? How can you easily understand whether it's right or wrong? Let's look at the answers. Can you see this is a huge number, right? It's 106 millions. If it's a huge number, the 10 to the power will be raised to a bigger power. It's a positive power always. This is a huge number, so you need to multiply this number with a huge number as well. Whereas look at this. It's a small number. It's a very, very small number. So you need to multiply with 10 to the power small number. Whereas minus 10 is a very small. It will make this number, when you multiply 5.61 over here, it will become very, very small. So this is one way to see. If you have 106, okay, it's 1.06, fine, and it should be a bigger number. So you can easily eliminate some of the other options if there are. Over here, since it's a very small number, you must have minus power. So this is about scientific notations.